Hello everybody, welcome back. Today we are going to go over the equilibrium and Le Chatelier's Regents practice. So if you haven't already done this, stop right now, go do these questions, and then come back and watch the video to review your answers. So let's just jump into this. Number 1, what represents chemical equilibrium? So if you go back to your notes, chemical equilibrium is you're flipping between two different chemicals. A cannot be right because it's the same thing. If you're switching between phases, that's phase equilibrium. That's what C and D are showing as well. Same compound, but different phases. So A, C, and D, those are your phase equilibriums. So B is the only answer to show the equilibrium between different chemicals. Okay. Number 2, when a reversible reaction is at equilibrium, the concentration of products and the concentration of reactants must be. This is constant. So concentration are constant. So when we talk about, and concentration just means amount of stuff. So with equilibrium, there are two things you need to know. Concentrations are constant, and the rates are equal. So the rate is talking about how fast something is going. Concentrations are showing the amount. So concentrations are always constant. Okay. Number 3, given the equation, when the concentration of Cl is increased, the concentration of Ag. So if we're adding Cl, that means we are going to be shifting towards the left. That means your Ag plus goes down and your AgCl goes up. That is what choice A is saying. So you have to figure out which way you shift and then how that affects the concentrations of each different thing. Number 4, it says some solid KNO3 remains at the bottom of a stoppered flask containing a saturated potassium nitrate solution at 22 degrees. What statement explains why the contents of the flask are at equilibrium? So, if we're talking about aqueous solutions, we're talking about things that are being dissolved. And if we're at equilibrium, that means the rates are equal. And then your concentrations are constant. So, constant does not mean equal, so it cannot be C. Concentrations are not greater, it can't be D. The rate has to be the same, so that's why it is A. Equilibrium, again, those two things, rates are equal, concentrations are constant. Now, constant just means the concentrations are not changing. They don't necessarily have to be the same amount. Okay, number 5, you have equilibrium exists in a flask with Br liquid and Br gas. And what is it? So we know it has to be phase equilibrium because we're going between those two phases. Then we have static and dynamic, and the answer is dynamic. Now, what dynamic means is that it's always moving, it's always changing. So it doesn't just reach it and then stop. It's kind of like it goes up, goes down, it goes up, it goes down, but it kind of averages out to be something very, 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 very similar. Okay. So dynamic is always going to be the answer. 6, when we're talking about phase equilibrium, so you want the same compound, but different phases. So, choice A, you start and end with two different compounds. Can't be that. Choice B, you have start and end with two different compounds. Can't be that. Choice D, you start and end with different compounds. So those are all examples of chemical equilibrium. And so you're only left with C, same compound being in the end, and you're only changing that phase. Okay. Number 7, the formation of ammonia. So that's talking about this. You want to make more of that side, so that means you want to shift towards that side. So the pressure ones take a little bit more time to explain, so let's jump down to C and D. If we remove N2, that means the left side is weaker, and you're moving towards it, and that's moving the wrong way. Same thing if you remove H2, because you want to move towards that NH3. And when we're talking about pressure, you want to go to when you increase pressure, you go to the side with the least amount of moles, sorry. So here we have 1 mole of N2, 3 moles of H2. So we have 4 moles of gas on the left side, and we have 2 moles of gas on the right side. So when you increase pressure, you go to the side with the least moles of gas, and then the side with the least moles of gas is the side we are looking for. So that is why it is A. Number 8, it's saying if you add a catalyst, what will happen? Catalysts do not shift equilibrium whatsoever. When we talked about potential energy diagrams, catalysts speed up reactions, but it speeds up the forward and the reverse reaction equally. It has no effect. That is absolutely wrong. So catalysts speed up forward and reverse equally. Number 9 is asking how essentially does a catalyst work. And so here's a sample potential energy diagram. The green is going to be a catalyst. Doesn't change where you start, doesn't change where you end, only changes the peak, so it lowers that activation energy. So if we're looking at this, C and D are wrong, because if you had the same reaction pathway, you'd follow the purple line exactly. That is not what is happening. The catalyst makes a new pathway, but it just starts and ends at the same place, and it lowers that activation energy, so that's why it is A. Number 9, it says, how can you shift towards the right? Again, add your L's and R's, it works. So if we add a catalyst, there is absolutely no shift. If we add more O2, it means the left gets stronger, and we move towards the right. That's our answer, but let's just look at the other ones. If we decrease pressure, so here we have 3 moles of gas. On the right side, we have 2 moles of gas. So if we decrease the pressure, we are moving towards the left. That is not what we want to do. And if we increase temperature, you're making the right-hand side stronger. So again, you're moving to the left. It is not what we want. That is why it is B. Number 11, given this equation, what happens when you increase H2? So when you increase H2, again, don't look at the answer choices first, just figure out what happens. So that means we are going to shift towards the right, which means that N2 is going to be used up and NH3 is going to be increased. So if we look at the answer choices, it says shift to the left. That is wrong. We know we have to shift towards the right. And then it says if we're talking about N2, N2 goes down, and that is C. Almost done here. Okay, number 12. Given the reaction, what happens? Well, how can you shift towards the right? Again, left, right, you want to go that way. So let's start from the bottom. If you increase temperature, you're making the right side stronger, because again, temperature is the same essentially as energy. So you move towards the left, not what we want to do. If you increase N2, it means the left is stronger, so we go right. That is the answer, but let's keep going. If you decrease pressure, you have 4 moles of gas on this side and 2 on that side. So if you decrease pressure, you move towards the left. Not what we want. And if we decrease H2, you also move to the left, because you always move towards the side you take from. That is why it is C. 13 says, what changes occur when the temperature is decreased. So essentially, if you're decreasing temperature, you're lowering that energy. So on your left side, your right side, you're moving towards that right side. So when you move towards the right side, N2 and H2 go down, NH3 goes up. So once you figured all that out, then you should start looking at the answer choices. And that is what D says. So H2 goes down, NH3 goes up. Okay. Almost done. Number 14. What changes cause the equilibrium to shift? So, pressure only affects gases, and there are no gases here whatsoever, so it can't be A. If we increase increase temperature rather, that's changing this, and so we will get a shift towards the right. If you add a noble gas, that just doesn't make any sense, so no. And then if you add a catalyst, catalysts speed up the reaction, but it does not cause a shift whatsoever. So the only one that makes sense is increasing temperature. Okay. 15 will shift towards your right when pressure is increased. Again, you need gases. And if you want to shift towards the right, that's that way. So A has no gases whatsoever, can't be that. B has no gases whatsoever. D has no gases whatsoever. And so C, you have 1 mole of gas on the left and 0 moles of gas on the right. So when pressure is increased, it goes to the side with the least moles of gas, and what's smaller, 1 or 0? 0 is smaller, so that is why C is the answer. Okay, last one. Given the equilibrium reaction at STP, again, we're not in the unit of gases, it doesn't matter. Which statement correctly describes the reaction, describes the system? So it's saying what is true about that reaction. So if we start for the bottom, and if we're at equilibrium and you see this double-headed arrow, again, if you see it like this, if you see it like that, that means at equilibrium. And again, we said that was concentrations were constant and the rates are equal. So the only thing that makes sense out of these 4 choices is A. And that is it. So this topic is very theory-based and takes some thought. So if you like just plug into a calculator, this is not that. It takes some thinking, but if you just think and take your time and practice, everything will be okay. Have a wonderful day.